so now let's look at another example and see if using energy approach would be beneficial compared to the force approach. So this is another typical question we've talked about, right? So if you shoot, this is just a vertical projectile motion. If you shoot something up with 5 meters per second, what is the maximum height? Maximum height that you can obtain, right? So in the olden days, you just go ahead and just brute force plug in the Suvat variables and the kinematics equations. You use that and you're done with it, right? But now let's see, can we analyze this? So again, what is a good place to set our height? Well, I would say we'll set height over here as 0, and over here the height would be h max, like this. Okay, so if you launch it initially with that, so what is the gravitational potential energy? So you can either do it in a table, or you can, yeah, there's a couple of ways to do it. So I'll let you choose, right? So you can do kinetic energy and potential energy and try to pick 0.1 and 0.2 like this. So in this case, this is my 0.1, this is my 0.2 over here. Right? So in 0.1, the kinetic energy is half m u squared, u being 5. And 0.2 is where the maximum height is. So there will be no longer any, that's momentarily, the kinetic energy is 0, right? There's no temporarily no speed over there. U initially is 0 because it's ground level. And then over there, it's mg. M is just the mass of this guy, and it's not given, but as you will find out, it's going to cancel out. And h is h max. Okay, so we're going to plug in. So I've plugged in the variables like this. And as you know, any change, so there's a couple of ways you can do it. You can do it with sort of matching the change. So any change in k is negative change in u. So what's the change? So final minus initial is negative of 1/2 mu squared. Does that make sense? The change decreases, right? The change in k decreases. Well, here you have kinetic energy, and here you don't. So the change is negative, right? So you went from having a lot of kinetic energy initially at this moment of launch until the final state where you have no kinetic energy. So the change is negative. So that makes sense, right? And minus, how about the change in u? Just should it be positive or negative without doing any math? Let's think. Well, the change in potential energy is it gained potential energy, right? Here it's h equals 0, it's not 0, right? So you can do it more rigorously and look over here. This minus 0, yes, it's positive. So it reinforces u, mg h max. Okay, what is your goal? Your goal is to find h max, all right? So you can cancel the m's and minus as well, get rid of that. So h max is 1/2 u squared divided by g, right? So u squared divided by 2g. Okay, now you can plug in the numbers. 5 squared over 2, 10. So that's roughly 25, right? 25. So 25 divided by 2. So that's 12.5 divided by 10 as well. So that's 1.25 meters. Okay, so roughly that way. And you're done, right? So no Suvat and just matching the change in. So over here, right, so you can say k is 0, u is mgh. Over here, k is 1/2. You don't even need a table. You can go just k is 1/2 mu squared, and u is 0, and you can directly use this. Or you can, if you don't like to use it in terms of the change, you can use the total. So E1 total equals to E2 total. You can start with this. So initially you have 1/2 mu squared plus, right, so just to show all the steps, K1 plus U1 equals to K2 plus U2. That's what I mean by we are only caring about 2 types of energy for most of the course. So here you have mu squared plus 0. If you want to be rigorous, you can say mg0, and then this mv. So here you plug in 0 square, just to show you if you want to show proper steps in your so your TA knows that you know the concept and you get all the partial credits in case you did something wrong, right? You can still get partial credits if you made a careless mistake. If you don't show your steps, you can't get partial credits. and U is mg h max. So the TA knows that you know the formula and you're plugging things in. Maybe even better is you add one more step of in between here is mv1 square plus gh1. So you are basically showing the grader that you know the formula for k and u, and you know how to apply numbers. And then the next step, you are actually plugging in the number. So you do one thing at a time, depending on how comfortable you are. Basically, the least comfortable you are, the more steps you should show, right? And but if you're very comfortable, you can, you know that this is, I am 100% confident I will get the right answer, right? So you can skip and just show the essential steps, okay? But just to let you know, you're taking a risk, so it depends on your comfort level. I always recommend showing the most steps possible in order to get partial credits. Yeah, so that's going to be 0. That's going to be 0. M cancels. I could have canceled the M first, but yeah, either way. So here I have 1/2 U squared left. Here I have GH max, and of course this gives me U squared over 2G. Same thing over here. So you can. I'm showing you both ways because sometimes, depending on the problem, they kind of have different. It's good to sort of know both perspectives. So whether you want to add up the total or just look at change. Some people find looking at the change easier. Some people find just tabulating the total and match them up easier. Okay, you can check that with Suvat. I'm not going to do that, but yeah, to and see if you get the exact same answer. So I'll leave that as an exercise for you. And you know the answer. We've calculated the answer. So try to repeat with the Suvat equations and see if you get the same thing, just as a quick exercise to find the maximum height. Okay. Now already you see the energy approach does something very well. It's very easy to within essentially, if you use, depending on which way you use, it's just a couple of steps and you get the final answer. But there is its limitations. For example, if I want to find the time it reaches the top, this does not help you, because if you look at the equation over here or here, right, look at all these equations, there's no time variable. So it does not help you to find the amount of time it takes to go to the maximum point. So there are limitations. So this is my recommendation from the first video is when you ask something like maximum height, the final velocity, whatever, consider if you can do it with the energy approach first. Usually it's easier. Okay, and the next one I'll show you in the 2D projectile motion, and sometimes this is a 1D motion. It's much easier with the energy approach, but sometimes it doesn't work. So you will have it's not built for that, right? To find the time. It's actually possible to find the time. It's just you need more advanced techniques. By that point, it defeats the point of using the energy approach. So might as well just use Suvat for that. So yeah, so you see the pros and cons. We'll see the next one where it really benefits with the energy approach. Okay.